The OSI model is a standardized architecture that defines network communication. In plain English, the OSI model simply provides a standard for different computer systems to be able to communicate with one another. But things weren't actually that simple in the early days. From the 1970s to the 1990s, believe it or not, a protocol war actually occurred where engineers, organizations, and even nations became so polarized over which communication protocol would result in the best and most robust computer networks. On one end, we had the OSI protocol described by the OSI model, and on the other end, we had the TCP/IP protocol described by the US DoD, that's right, Department of Defense model. Long story short, TCP/IP protocol ended up winning the war, as the OSI protocol was considered a bit too complex. But see, here's the kicker. The OSI model was selected, and to this day is used to describe TCP/IP communication. That said, let's dive right into it. The OSI model consists of 7 layers. First, we're going to be talking about the application layer. This is the human-computer interaction layer, and it is responsible for protocols and data manipulation that applications rely on for accessing network services and presenting meaningful data to the user. Next, we have the presentation layer. This layer is responsible for the translation, encryption, and compression of data. Data translation simply involves preparing the data into well-known formats for applications. File-level encryption simply ensures security of the data as it travels through the protocol stack. Data compression improves the speed and efficiency of communication by minimizing the amount of data that needs to be transferred. Then comes the session layer. Now this layer builds, maintains, and terminates communication between 2 devices. A session is simply the time between the communication is opened and closed, and each session is tracked with the help of session IDs. Other services offered include authentication, authorization, and synchronization. Let's talk about what those terms mean. Authentication is simply the process of verifying that you are who you say you are. Authorization involves verifying that you are permitted to do what you are trying to do. Synchronization includes adding checkpoints within data streams. This ensures that data streams up to the checkpoints are successfully received and acknowledged. And in case of any failure, only the streams after the checkpoints have to be retransmitted. The transport layer is concerned with the end-to-end communication of data between 2 devices through data segmentation, reassembly, flow control, and error control. The layer also identifies communication between different applications through the use of port numbers. In plain English, data segmentation involves breaking up data received from the session layer into smaller chunks called segments, before sending it further down in the OSI model. Now on the receiving end, the same transport layer is responsible for reassembling those data segments before passing it up to the session layer. Flow control determines the optimal speed of data transmission and ensures that the receiver doesn't get overwhelmed with data from the sender, whereas error control ensures the integrity of the data received. Now below this is the network layer. This layer is responsible for delivering data between 2 different networks. It involves breaking up segments from the transport layer into smaller units called packets on the sender's device, and then reassembling them on the receiver's device. This layer also helps find the best path for the data to reach its final destination, also known as routing. Then comes the data link layer. It facilitates data transfer between 2 devices on the same network. The data link layer takes packets from the network layer and breaks them down into smaller pieces called frames. Now, similar to the transport layer, the data link layer is also responsible for flow control and error control. The difference, however, is that the transport layer only does it for inter-network communications, whereas the data link layer does it for intra-network communications. Finally, we have the physical layer. This includes the physical equipment involved in data transfer, for instance Ethernet cables, optical fibers, radios. This layer is also where the data is converted into a stream of bits, so ones and zeros. The physical layer of both devices also need to agree on a signal convention before any sort of data transfer can begin. And the type of signal simply depends on the medium connecting the 2 devices. For instance, this could be electric for copper wires, light in case of optical fiber, and radio waves in case of air. And that is the end of our discussion of the OSI model. Thank you for listening, everyone. Take care.